Burnt Tree Hill Observatory. This video shows the construction of the Burnt Tree Hill Observatory in eastern Washington. It was built on land that had been damaged during the Taylor Bridge fire a few years earlier. It's dark here. I think I'll build an observatory. Gee, it's not very level, the boss said. And are you sure this is a good idea? There are several dead trees that need to come down. And there are stumps. Big stumps. I excavated a level spot with a dingo, backfilled it with gravel, and then started building my retaining walls for the base of the observatory. I made a model of the telescope and the telescope mount in Blender, and then I modeled the size of the building and the location of the walls and the roof, and I manipulated the model using Blender's armature features to make sure that the telescope wouldn't hit the walls anywhere. It's a tight fit, but it looks like it's going to work. The walls are made from 8 by 8 by 16 inch Allen block, which weigh about 80 pounds each. The pier is a 3 foot by 3 foot thin slab with a 32 inch square concrete masonry unit hollow box, which is mortared in place. The floor beams were sawn at a local mill from trees which were salvage logged from the property. 2 inch by 3 inch steel joists support the floor. This is fire country after all. You can see here some stub joists I had welded at a local shop. The floor is 1 by 6 aluminum decking from Nexan. It's built like a deck to help cool air circulate through the building. Meanwhile, I started working on the beams which would support the roll-off roof. These are 3 by 5 inch steel tube. It would be far too heavy for me to manage as a single piece, so I made these splice plates and drilled the tube at home on my drill press. Here you see the beams on the walls. The rough framing is done with Drycon fire retardant 2x4s. The framing was then sheathed with a commercial fiberglass gypsum sheathing board. It's also fire retardant, can be exposed to the weather for up to 6 months before receiving the final outer sheathing. The roof also uses steel rafters. I fabricated the roof in my driveway, disassembled it, and then reassembled it in place. The snap-lock metal roof matches the cabin's roof. There is a removable wall panel on the west wall. It's framed using lightweight steel studs. It allows the telescope to point all the way down to the western horizon. All through the summer months, wildfires raged through the west. The Jolly Mountain fire was only 10 miles from us. Finally, in September, some good friends of mine came over and we moved the telescope across the mountains and installed it in the observatory. It's a custom-designed offset equatorial mount which carries a Meade 16-inch f10 telescope. It uses Bayer's drives and a custom control system which I programmed myself. First light was on September 23rd. I was able to achieve an excellent polar alignment, and because much debugging of the custom mount had already been completed, the first images were very satisfactory. The next month, I was able to finally achieve imaging of objects down to 20th magnitude, as shown in the single image of 10 galaxies and 5 quasars. The goal has always been to reach 20th magnitude within a 10 to 15 minute exposure, and this has now been achieved, and it was done using a completely stock Canon DSLR camera.